Okay, so Meta AI has just revealed its latest breakthrough invention, which is definitely just a harmless advancement that won't impede on your sovereignty or privacy. An AI system that can read your brainwaves to let the computer perceive what you're seeing with your own eyes. So get ready as we cover the 3 core components powering this newly unveiled AI system. Plus, we'll dive into a bonus to explore the significance of this self-supervised learning technology and its trailblazing discoveries. First, though, it's important to note that Meta's new system actually functions by using magnetoencephalography, which the AI system uses to measure magnetic fields that are produced by the neural activity of the brain, which also provides a deeper look into the mystery of how human intelligence works. Most significantly, though, this technology serves as a stepping stone towards creating non-invasive brain-computer interface technology, so that Elon doesn't have to drill a hole in your skull. Just think of the potential of this kind of technology being used in a clinical setting to assist those who have been rendered voiceless or unable to move due to brain injuries. Or think of the potential that this kind of technology would pose for the government to monitor humans for potential thought crimes to preemptively imprison them. The possibilities are endless. And here's how it works. At its core, Meta's new AI model is constructed upon a 3-pronged architecture, each serving a distinct yet interlinked purpose. The first part of this architecture is the image encoder, which crafts an image representation that is independent of the brain. Next, the second part of this architecture entails the brain encoder, which acts as a bridge and synchronizes the magnetoencephalography signals using image encodings. Finally, the third part of the architecture outputs through the image decoder, which draws from the brain's representations and then crafts a plausible image. This intricate coordination of encoders and decoders was originally designed for decoding speech perception using the brain's signals, and the dataset fueling it consisted of the magnetoencephalography recordings sourced from the global research consortium called THINGS. But now for the actual breakthrough. The aforementioned technology was what led to the riveting discovery where the research team found that AI systems, especially self-supervising AI models like DynoV2, actually align seamlessly with brain signals, which means that when both the human brain and AI view the same image, they activate in an eerily similar pattern. It's as if these AI systems are mirroring the neural intricacies of the human brain. And while other tools like functional magnetic resonance imaging can yield more detailed images, the superpower of Meta's new AI decoder lies in its speed, being able to generate images from brain activity in mere milliseconds. Notably, these visuals are still somewhat lacking in fine details, but they can still accurately capture the broader essence of what the human eye is perceiving. Now for the bonus look into what this technology is leading up to. By just connecting the dots of progress made, Meta's future research trajectory is becoming clearer. For one, last year Meta introduced a novel AI architecture aiming to break existing limitations in order to think and act like humans. Then, a collaborative research endeavor involving both Meta AI and New York University showcased iJEPA, a visual AI model founded on the Vision Transformer architecture, which has the capability to predict unseen image segments. Now, the researchers at Meta AI are theorizing that these abstract image representations can be pivotal in crafting AI models that mimic human learning, marking a paradigm shift in how AI perceives, learns, and possibly thinks, meaning that AI might not just read your mind, but could potentially become you altogether and take your place. Thus, we are at the cusp of this AI-powered revolution where the lines between human intelligence and artificial intelligence will be blurred to where you may no longer have to think. And hot on the heels of Meta's cutting-edge AI decoding of brainwaves, NVIDIA is also propelling the AI world even further into the future with the help of robots, as the tech giant has just unveiled its latest generative AI for robotics and industrial enhancements that have come to its Jetson platform. Here we'll explore 4 key points of NVIDIA's recent advancements. Number 1. Making robotics adaptive and intuitive. NVIDIA's enhanced Jetson platform for edge AI and robotics is changing the game with the integration of generative AI with robots and edge devices to allow them to learn from minimal or sometimes even zero examples. Imagine vision transformers identifying unfamiliar objects without the painstaking process of training a new model, This means that systems are no longer just automated, but now they're also responsive and adaptive. Additionally, a natural language interface further simplifies AI interactions, as showcased in NVIDIA's demonstration of a computer vision system that recognizes objects through mere text descriptions. Number 2. A growing nexus of renowned clients. The Jetson platform's adaptability and efficiency haven't gone unnoticed. A rapidly expanding clientele boasts over 10,000 customers. Some of the noteworthy names include giants like Amazon Web Services, Cisco, Pepsi, and Siemens, highlighting the platform's broad appeal across various industries. Number 3. The open-source Jetson Generative AI Lab. In its bid to drive innovation, this initiative allows in-house developers to harness the power of the latest open-source generative AI models. Moreover, the NVIDIA Tao Toolkit, a tool for edge model optimization, is receiving an upgrade with the introduction of Visual Change Net, which is a transformer model specialized for defect detection. Not to be left behind, NVIDIA Orin proudly stands as the only edge AI hardware capable of running several foundational models, such as the Meta's Llama 2 large language model. Number 4. Elevating robotics and video AI platforms. NVIDIA continues its trajectory of innovation with the release of the Isaac ROS 2.0 and Isaac Sim 2023.1. These robotics and simulation frameworks aim to streamline the development of AI-driven robotics applications, particularly in the realms of perception and simulation. Furthermore, by year-end, the Metropolis platform for vision AI applications is set to receive a boost with the introduction of new APIs and microservices. Finally, NVIDIA's Jetpack will also soon launch with its upgraded 6.0 version. And on top of NVIDIA's revolutionary push into generative AI for robotics, NVIDIA researchers, along with Stanford and UT Austin, have just unveiled another groundbreaking development called Cross-Episodic Curriculum, or CEC. The question they set out to answer was whether data-intensive AI algorithms can effectively function in data-scarce domains like robotics, with CEC being a novel algorithm to address the data challenge in 3 vital ways. Number 1. Curricular design. By leveraging transformer models, CEC integrates cross-episodic experiences to formulate a stepwise learning path, enhancing the agent's skill evolution. Number 2. Demonstrated efficiency. CEC's effectiveness is highlighted by 2 test cases: Google DeepMind's discrete control multitask learning and RoboMimic's continuous control imitation learning. In both instances, CEC's curriculums allowed AI agents to master increasingly intricate tasks progressively. Number 3. A 2-step implementation. First, curricular data preparation structures the events in a sequenced manner, spotlighting the learning patterns. Second, cross-episodic attention model training trains the model, allowing it to reflect on past episodes, resulting in more efficient learning.